Today we're going to be talking about parabolas. We can see a rough graph of one to the left with its representation as y equals ax squared plus bx plus c. As we know, since the parabola is opening up, or if the parabola is opening down, we modeled by the same general function. We know that parabolas have an axis of symmetry, which for parabolas opening up and down can be represented by x is equal to negative b over 2a. This line right here will represent a parabola's axis of symmetry if the parabola is opening up or down. And to find the parabola's vertex, we can simply plug in the line of symmetry equation, which is x equals negative b over 2a, into the general function. As we know, the line of symmetry along with the general function must satisfy the vertex point. Therefore, we can rewrite the vertex equation as a times b squared over 4a squared plus b multiplied by negative b over 2a, or x plus c, which can then be simplified as b squared over, to cross out the a, as b squared over 4a minus b squared over 2a plus c. And to simplify this further, we give each of the fractions a common denominator of 4a, which this can be written as b squared over 4a squared, over 4a minus 2b squared over 4a plus 4a c over 4a, which we can then combine into 4a negative b squared plus 4ac right here, which will represent the y term for the vertex, which we can rewrite the vertex of a parabola in general form as negative b over 2a, comma, negative b squared plus 4ac over 4a. This will be the general point for any vertex modeled by the general function of y equals ax squared plus bx plus c. And now that we have its axis of symmetry and its vertex out the way, we can find a vertex's focus point and its directrix. And since we know this as a parabola is a conic section, and we know all conic sections have a focus point and a directrix. For the focal distance, which we're going to represent as p, p's definition is 1 over 4a, the same a as the coefficient of x squared right here. Now we know the focal distance definition is distance between the vertex of a conic section to one of its focal points or its directrix, which the directrix of a parabola will look something like this, with, as we know, the same distance as we would from the vertex to the focus point right here. Right here. This distance will also be p, which, for more specifically, we can find the directrix of a parabola represented by the equation of y is equal to negative b squared. Let's check our vertex. Yep, it's negative b squared plus 4ac over 2a minus p. And this will be the function for a directrix of a parabola represented by the general function right here, which likewise you can find for the focal point of a parabola by simply adding p to the vertex, which we simply, right here, we add p. This will be the focus point for a parabola, as we know that both the vertex and the focus point of a parabola will always lie within the parabola's axis of symmetry. And with that, we can find one more peculiar thing about a parabola, which is a parabola's eccentricity, which I'll be covering in more detail in the next video. The eccentricity of a parabola will always be 1, or in other words, the straight distance, the locus of all points. Here we can go at any point. Let's say we go here. Its ratio to a perpendicular line to the directrix will be a constant, which the constant will be 1, as this length right here, this red length, divided by this blue length will give us 1, exactly 1. But this graph is not drawn well, but you can imagine this in your mind. And this will apply for all points, so you can go from here to here, divided by its perpendicular line down to the directrix. So the pink line divided by the gray line will give us 1 again. And this will be important for later discussions of how to deduce what a conic is simply by looking at its general function. But for now, we will understand these content, and if you have any questions, please do consider commenting on the comment section below, and I hope you have learned something new.